All right, in this video, we're going to introduce complex numbers and looking at writing square roots of negative numbers as imaginary numbers. So imaginary numbers arose from trying to solve equations such as x squared equals negative 1. If we try to solve this, get it equal to 0, we're not going to be able to factor x squared plus 1. And if we use the quadratic formula, what will happen is we'll get a negative inside of our square root. So our discriminant will be negative. And as we saw in the previous section, if the discriminant is negative, you don't get any real solutions. So if we take the square root of both sides, we get x is the square root of negative 1, which we define the imaginary number or the imaginary unit I to be that value, where I is the square root of negative 1. So in essence, it became an issue of, well, we can't solve this for real numbers, so let's create this new set of numbers called imaginary numbers, where the imaginary number I is the square root of negative 1. It's the solution to this equation. And it turns out that as crazy as it may seem, imaginary numbers actually have a lot of real-world usage. If you get into electrical engineering, you'll be dealing with a lot of imaginary numbers. They just don't use the letter I for imaginary numbers. They use the letter J. I believe I is what they use for current, so they didn't want to create any confusion, so they use J instead of I, but it means the same thing. So when writing out square roots of negative values as imaginary numbers, we can factor out the negative 1 square root of negative 1 from the expression under the following condition, and that is as long as what remains after we factor out a square root of negative 1, as long as what remains is the square root of a positive number, which we're going to see in our examples. But so let's just go ahead and for instance, we have the square root of negative 25. We can write that as the square root of negative 1 times the square root of 25. So we could factor this square root of negative 1 out from the square root of negative 25, because what remains, this square root of 25, it's the square root of a positive 25. So square root of negative 1 is I, and the square root of 25 is 5, so we get I times 5, which is 5I. So just pretty much you're factoring out the square root of negative 1 and then simplifying the square root that's left over. So example 1, part A, we have the square root of negative 36. We can write that as the square root of negative 1 times the square root of 36. The square root of negative 1 is I, and the square root of 36 is 6, so I times 6 is just 6I. Part B, square root of negative 100. Well, we can write this as the square root of negative 1 times the square root of 100. And the square root of negative 1 is I. The square root of 100 is 10, so I times 10 gives us 10I. And part C, we have the square root of negative 8. So that's the square root of negative 1 times the square root of 8. Now we know the square root of negative 1 is I, but for the square root of 8, we need to find the largest perfect square that goes into 8. And the largest perfect square that goes into 8 is 4. So the square root of 8 is the square root of 4 times the square root of 2. Which the square root of 4 gives us 2 times square root of 2 for the square root of 8. Also, friendly reminder, I do have a video in the Desmos playlist for how to use the table feature for Desmos to simplify the square root of 8. So square root of 8 is 2 times the square root of 2, and we still have the square root of negative 1, which is I. So we just write 2 times I times the square root of 2. All right, that about does it for this video. Thanks for watching. I'll see you next time.